Hi, hello again. This will be the third part of our lecture for the second chapter. It's second chapter. This time we'll discuss about Bernoulli's energy theorem or Bernoulli's energy equation. So what is this energy theorem? Which was demonstrated by Daniel Bernoulli. Maybe you have heard about him before, you know? So he demonstrated this theorem before in 1738 yata. I'm not so sure about the year. You can look into your modules. Okay, so ano tong energy theorem na to? Ano bang sinabi ni Daniel Bernoulli before? So, sabi niya, in any stream flowing steadily without friction, so there's the assumption there, without any friction, the total energy contained in a given mass is the same at every point in its path of flow. In other words, kinetic energy, pressure energy, and energy of position or the elevation energy may each be converted into either of the other two forms theoretically without loss. So sabi ni Daniel Bernoulli, let's say for example, although the figure already yun na yung figure dun sa module ninyo. Let's say for example, let's make a different figure to explain this theorem. Let's say for example, we have a conduit, certain liquid flows through it, and we have 2 points here. Cut natin two sections, let's say section 1 and section 2. I-divide natin yung pipe into 2 sections now. Sabi ni Daniel Bernoulli, yung energy at point 1, sabi niya, without any loss of energy or loss due to friction or any cause, the energy at point 1 is equal to energy at point 2. So if the particles of the liquid travels from point 1, so pag nag-travel yung particle ng liquid papunta sa point 2, wala daw, the same pa rin yung energy ng particle na yan. So lahat ng particles ng liquid, for example, ito yung mga particles na nauna, nag-travel sila papunta sa point 2, walang energy. So parehas lang yan. Of course, that is based on the law of conservation of energy, which states that anong law of conservation of energy? Energy cannot be created nor destroyed, but it can be transformed from one form to another. Since energy cannot be created, ibig sabihin hindi pwedeng madagdagan yung energy niya along the way kung wala namang pump dyan or anything, any device that will increase the energy. So pag ang energy niyan, it cannot be created, it cannot be destroyed, so hindi yan mawawala, hindi rin yan magkakaroon ng energy. It cannot be created or nor destroyed. So yung energy ng particle at point 1 should be equal to the energy of particle na yan nung pumunta siya sa point 2. So that's the theorem, Bernoulli's energy theorem. So without any loss, theoretically, the energy at point 1, which is equal to V1 squared all over 2G plus P1, the pressure at point 1 all over gamma, plus the position at point 1 or the elevation at point 1 should be equal to the velocity at point 2 plus the pressure at point 2 plus the elevation at point 2. So this is the ideal or the theoretical form of the Bernoulli's energy equation. Now, ang nangyayari, this is not actually the case in reality. So in reality, this is not the case. So theoretically, this is correct because based on the law of conservation of energy, But in reality, that's not the case. So energy at point 1, the particle, yung energy ng particle na yan, di ba na-energize yung particle, kaya siya nag-move. So pagdating niya sa point 2, hindi na yun yung original energy niya. So what happened along the way? Ano bang nangyari along the way? So nangyari is that nagkakaroon ng loss of energy. Hindi naman siya actually nawawala, no? Since we are at the mercy of the law of conservation of energy, it cannot be created nor destroyed, no? Ang ibig sabihin ng loss of energy, merong na-transform na energy into a different form, no? So habang nagtra-travel yung particle from point 1 to point 2, yung energy niya na-transform sa ibang energy, no? It's like for example, kapag tumakbo ka from College of Engineering, tumakbo ka papunta sa administration building, then yung energy mo initially dito sa College of Engineering, nung nakarating ka na sa administration building, syempre meron ng nawalang energy, ano. Ayan. So along the process, so ito yung theoretical, yung wala pang loss na energy. So along the process kasi, so the equation now, ang nangyayari dyan, let's try to draw the situation. So this is point 1, this is point 2. So nangyayari, let's consider a particle, ang nangyayari kasi, kaya may nawawalang energy, hindi naman siya nawawala, natatransform siya sa ibang form ng energy. Nagkakaroon ng friction, may nabubuong friction sa may wall between the particles of the liquid and the wall of the conduit. Pwedeng pipe or pwedeng channel, ito yung conduit. So nagkakaroon ng friction dito, at kapag may friction, ano bang naproproduce kapag may friction? Okay. Friction produces heat. So that's it, no? Kapag may nawawalang energy, some energy, some quantity, yung energy natin ay natatransform sa heat energy. Ayan. So hindi siya nawawala, natatransform lang siya sa other form ng energy, which is heat energy, and we call that frictional loss. Ayan. Frictional loss or loss due to friction, loss of energy due to friction. So ang nangyayari now, to satisfy the law of conservation of energy, nag-add tayo ngayon sa equation. So the energy at point 1 now is equal to the energy at point 2 plus the loss due to the head loss due to friction. And there are other causes of losses of energy, just like bends. Kapag may 90-degree bend, 45-degree bend, okay, may sudden contraction, yung pipe biglang lumiit yung diameter. Mga reducers tayo na ganun, ano? O may mga reducer, biglang yung maliit na diameter biglang lumaki. Yan, yung diameter ng pipe. So merong corresponding loss of energy because of those obstructions, ano. But the main component or the main contributor sa loss of energy would be the frictional loss. Yan. Now, to satisfy still the energy equation, so the energy equation with head loss now would be equal to E1, energy at point 1, equals energy at point 2 dito, plus yung head loss. Para masatisfy pa rin yung law of conservation of energy. Ayan, that's the gano'n na yung nangyari in reality. For chapter 2, hindi muna natin concern yung frictional loss, kung may head loss man na involved sa equation natin given yung head loss. But in the succeeding chapters, we will be solving for the losses due to friction and losses due to minor losses such as bends, obstructions, mga gate bulbs installed along the pipe, no? But for this chapter, head losses would not be computed, but ibibigay natin yan sa mga problems. Para practice lang natin how to apply the Bernoulli's energy theorem or equation. Practice lang natin. Ayan. So, next would be, sir, paano kapag may pump in between? Diba, meron tayong balon. Balon bang balon? Tama. May pump, from balon papunta dun sa second floor ng bahay. So, syempre hindi naman makakapunta yung tubig o yung liquid from a lower to a higher elevation kung wala tayong pump. Okay? So, we need pump. So, saan natin, yung pump na yan? How do we include that in the energy equation? So, let's say for example, kapag meron tayong pump in between points, so these are just schematic diagrams. So, let's say this is a pump. So, this is point 1 and this is point 2. So, para mag-travel yung para mag-move yung tubig or yung liquid from point 1 to point 2, kailangan natin ng pump. Okay. So, how will the equation look like? Ano yung equation natin? How would the equation would look like? Okay, so that would be, ano bang silbi ng pump? It adds energy in the system. Nag-add siya ng energy. So, that means, yung energy equation natin would be equal to E1 plus yung energy, since kung mayroon tayong initial energy dito, may na-add pa na energy. So, let's say HA, ang notation natin for pump. That should be equal to the energy at point 2 plus yung head loss from 1 to 2. This should be from 1 to 2 pala. So, head loss from 1 to 2. Kasi meron pa rin mga frictional losses yan along the way. Ayan. So, E1 plus HA, yung head ng pump, and then energy at point 2 plus head loss from 1 to 2. So, that would be the energy equation with the pump. Or if you try to expand that, expand natin yung equation, it would be equal to, so A1 is equal to B1 squared over 2G plus P1 over gamma plus Z1 plus the head contributed by the pump, or the energy contributed by the pump, that is HA, that should be equal to B2 squared all over 2G plus P2 over gamma plus Z2 plus yung head loss from 1 to 2. 1 to 2. Yung head loss from 1 to 2. Okay, so that will be the expanded form kapag meron tayong pump. So, paano kapag may turbine? So, kapag may turbine between points 1 and 2, paano kapag may turbine? Ano bang silbi ng turbine? So, let's say turbine between, so this is a turbine. So what happens kapag may turbine? Ano ba ang ginagawa ng turbine? So turbines extracts energy. So they extract or absorb energy and transform them to a different form of energy. So saan ba nakakita ng turbines? So you usually see turbines kapag sa mga hydroelectric power plants, ginagawa nila. So usually sa mga hydroelectric power plants, mayroon tayong dams. I think I have explained this before noon sa hydraulics when we discussed dams. So meron tayong turbine dito sa baba, merong conduits dyan. So kapag mabilis yung flow ng tubig, syempre mas mabilis yung ikot ng turbine. Then meron tayong outflow dito. So umaandar yung turbine because of the flow of liquid or water No, dyan. So, extracts energy. So, turbines extracts energy. So, what happens kapag may turbine, ang equation natin from 1 to 2, so since in-extract niya or nag-absorb siya ng energy, so from 1 to 2, so E1 is equal to energy at point 2 plus yung head loss from 1 to 2 plus yung energy absorbed or extracted by the turbine, let's say HE tawag natin dyan. So ito yung dam natin, dam. So yan, nag-absorb siya ng energy and convert it to a different form of energy. Okay, so if the expanded form would be, so V1 squared all over 2G plus P1 over gamma plus Z1 is equal to V2 squared all over 2G plus P2 over gamma plus Z2 plus yung head loss from 1 to 2 and then plus yung, so this is the expanded form of the equation kapag may turbine tayo. Okay, so ano naman, how do we compute for the power required by the pump? Kapag ang required, usually naman ang ginagawa natin kapag halimbawa na may nagtanong sa'yo, sir, gusto kong ano kaya ang ilang power kaya ang bibilhin ko ng pump para mapalagyan ko ng tubig yung tangke namin sa third floor. So hindi naman hinuhulaan yung power na yung pump, ano yung power ng pump, no? Oh, okay na yung 1 horsepower, okay na yung 2 horsepower na pump. Okay, so hindi basta-basta ganoon. So what do we do is we compute, no, yung power required. So meron kang dalawang elevation, so lang kaya ang kailanganing power. So we compute for the power required by the pump is equal to Q gamma times yung HA. Okay, HA is yun yung na-compute natin using energy equation kanina. Na-erase ko na. Okay, gamma, usually water naman yan, ano? So, gamma ng water and the discharge. Yan. So, yung HA natin, yeah, that would be coming from the energy equation kanina. This is a linear quantity in meter or in feet. So, power extracted by the turbine, okay, extracted by the turbine, that's Q gamma HE. Ito. Parehas lang, nag-iba lang would be the notation, ano. Okay, so that's how we compute for the power extracted by the turbine and the power required sa may pump. Ayan. So, what else? Ano pa yung kailangan natin intindihin? The concept of hydraulic grade line and energy grade line. Ano ba itong grade line? So, from the term itself, grade line is just a graph. No? So, yung hydraulic grade line kasi, there are two energies involved here. No? The kinetic energy and the potential energy. Usually, kaya yung tinatawag natin na ano, pag-aralan muna natin. Yung kinetic energy and then the potential energy. Kinetic energy is the velocity head. Potential energy is the elevation head. And the pressure head. So, dalawa lang actually ng forms ng energy ang natin. Ina-apply natin dito. That's kinetic energy and the potential energy. No? So, under potential energy, we have the elevation head, energy, and the pressure energy. So, the hydraulic grade line is just the graph of the potential energy. So, for example, ito yung piping system natin. A better illustration is in your module. So, pag graph natin yung energy at point 1 and point 2, so meron tayong elevation, meron tayong pressure energy. Elevation, pressure, energy. So, pag dugtungin, may naglalagay tayo ng mga piezometers dyan sa dalawang points na yan. You can include more piezometers in between. Then, pag kinoconnect natin yan, yun na yun. Hydraulic grade line. That's the graph of the potential energy. Yan lang. That's the hydraulic grade line would be the graph. No. So, yan. And then, the energy grade, of course, is not always ganito. No? Meron pang ibang items na involved dyan. Just for illustration purposes. No? Well, point 1, gusto mong i-graph yung hydraulic grade line ng point 1 and point 2. O, maglalagay ako ng piezometer. Ano ba yung mga energy na nandito? Okay, so ano yung elevation niya? Ano yung pressure niya dyan? Pressure head, elevation head. Okay, linear quantity naman yan. So, yun yung height. Yung height na yan is the energy at point 1. Yung height na to, energy at point 2. That's the sum of elevation and pressure energies or heads at that point. So, pag pinagdugtong natin yan, okay, we will form a line. Yung graph niya, we call that the hydraulic grade line. Next would be the energy grade line. Ano ang energy grade line? Graph yan ng total energy. That means that would now be kinetic energy would now be included in the computation of the total energy. So, total energy at point 1, total energy at point 2. Pag graph natin yan, you draw a line. That's the energy grade line. Now, of course, since may loss of energy, may difference in elevation yan, yung mga graph nila. So, may slope yan, yung energy grade line, may slope din yung hydraulic grade line. So, yung difference niyan, yung difference in elevation, pag graph mo, is the loss of energy. So, we call that the loss of energy. So, that's how we graph the energy grade line and then the hydraulic grade line. So, that's it. Next parts would be now the application of all the things we have discussed. Energy equation, efficiency, Bernoulli's energy theorem, yung power extracted by the turbine, and the power required dun sa pump. So, all of those concepts would be applied na in the succeeding parts of our discussion. So, yan. So, that's it for now. Wait for the next video.